much. It's honestly a pleasure and honor to be here with you today. Thank you. So my name is Hend. I'm a PhD student at the University of Sheffield in computer science, and I work with speech technologies. Oh, these are my supervisors. And my work is basically trying to make speech technologies fair and inclusive. And in the next 15 minutes or so, I'll tell you a bit more about that. So first of all, let me give you more of a general example of not directly related to speech. But has anyone heard of the trend that was going on a couple of weeks ago of asking ChatGPT to draw a picture of what your life looks like? If you haven't, try it out. So I did. I asked it to, well, I gave it a brief introduction about me, literally what I told you, that I'm I'm doing a PhD in computer science. And this is what I got as a result. Well, first, it doesn't look like anything like my life, but I was surprised that it assumed that I'm a guy. And it didn't even ask me what my gender is, it just assumed and gave me the picture. And I tried it a couple of times, and I noticed when I change it to I'm in a nursing school, it then gives me, it assumes again that I'm a girl. So this is really an example of bias within the AI. And this topic has been going on for years. It's not new. But this is essentially an example of some stereotypes or bias in the society gets propagated into the AI models that are used in most of our applications today. Now, my work is not with ChatGPT, it's more with speech technologies. And we use speech technologies daily, whether you know it or not. But examples of these speech technologies are the speech-to-text, which is also called automatic speech recognition. I bet everyone here talked to either Siri or Alexa, so these are examples of speech-to-text systems. In radio, it's more commonly used to do auto-transcription, so generating transcripts from the interviews or show, which makes it easy to search the show or even for archiving them.
Bionics also use a similar system to transcribe their voice notes that are coming from listeners, so that they get a summary of what is being said. And Speechmatics is also widely used to do real-time capturing of what people are saying in a conference or an event. So this is all example of speech-to-text technologies. There's also the speech enhancement, which is used when we make phone calls, to make our voices better when we're talking to each other over the phone. Also in the mics to enhance the quality of the speech, so having like noise cancellation or echo cancellation, and also used in hearing aids to enhance the speech that they're hearing. Also used in radio and broadcast in general, the speech translation, where it automatically translates the speech into a different language, so reaches a wider audience. And finally, there's text-to-speech, which I found out there is a entire radio channel that's based on AI voices, which basically allows the listener to have a 24/7 content. The songs are not AI, but there are voices in between the songs that, well, here's an example, it's easier.
I'm completely AI.
So am I. Me too. We all are. This is Radio GPT. Welcome to 100% AI. Anything a radio human can do, I can do better.
It's not better, but it's just an example. And similarly, it's used to do voiceovers in ads and similar. So the technology is there, it exists. But what we might not know is that there is bias in there. I'm going to be talking more about automatic speech recognition, so I'll just give you a bit of an overview of what this technology is very briefly. So it's basically taking an input speech, which is usually an audio recorded, and then it passes through multiple processes and through an ASR model, and the output is just the text. So it takes the speech and converts it into text. This, of course, requires a lot of machine learning and signal processing, and it's not an easy task, but it involves AI, of course. Now, the ASR model in research, we commonly use either CalD or Whisper, which I'll also be mentioning. So these are just speech models that we can create to do the automatic speech recognition. And to evaluate these models, we take the output from the model, which is the predicted text, we compare it with the original text, and we compute something called the word error rate,
And basically, we aim for this to be as lower as possible. So if we're comparing two models, the lower one is better. So you'll need that kind of information for the rest of my talk. Now, moving forward, I've asked to demonstrate what bias looks like in speech. Another fun fact about me, I have a twin brother. So I asked him to just record himself saying one of the tongue twisters, which are considered challenging for a speech recognition model. So this is Muhammad saying the sentence.
How much mud could a mud duck chuck if a mud duck could chuck mud?
He had no idea why he's doing this, so it's just why he sounds a bit confused. And this is the output of, so I used here one of Whisper's models. So it pretty much got him, except just one word it got wrong, or a couple of, just one word. And here's me saying it.
How much mud could a mud duck chuck if a mud duck could chuck mud?
I thought I did a good job, but it actually did not get any of the words. And it was the exact same model, the exact same sentence, and we are the same age, same nationality, but it gave a complete different output. So this is just an example of what we call a bias against, well, in that case, women, but it's not generally that's just a general example. So the speech technologies are biased, and when I say bias, I'm referring to a discriminatory output that's discriminating against certain groups or individuals. And in research, we quantify that as a performance gap. The Stanford research actually showed that the existing speech, the state-of-the-art ASR models like by Amazon or Apple or Google actually have racial bias, such that they perform much worse with black speakers compared to white speakers. And this bias can arise from different sources, of course, but more commonly, the data that the model was trained on is unrepresentative of the population. Or the context that the model was developed in is different to the context that it's actually being used in. So this could make the bias arise. This could, of course, have significant effects on the end users. So if, for example, in a healthcare application, the inaccurate recognition could lead to misdiagnosis, or in general systems, it could lead to offensive responses, which does happen. So the bias does have significant effects. My work is more related to the gender bias. So typically, a system would have a performance gap between women and men, for example, and I'm trying to find a way to have something like this, which is more fair so that we have a similar performance with both genders. So what I did in an initial study is I took the data, which seemed to be the most influencing factor. So I used a very popular data set, LibriSpeech, which is basically people reading off textbooks or fiction books. So I took the data set and created subsamples from this data set containing different gender distributions. So starting from having 0% women in the training set up to 100% women. So in general, I had 11 subsamples of the train set with different gender distributions. And then I took each of these data sets and trained a model. So I trained the same model using different data sets. And then I evaluated the model by passing the same test set, which is gender balanced, to see, sorry, need to pick it a bit. So I evaluated using the same test set, which is gender balanced, computed the output, which is the text, as I told you, and evaluated it by computing the word error rate. So basically, I was trying to see what happens when I increase the percentage of women in the training set. How does this affect the performance of the system? So my hypothesis was the gender distribution would have an effect on the performance and fairness of the recognition. So this is what I found. The woman percentage did have an effect, so it does affect the performance of the system. But when I tried it with Caldi, I got more. So this is a plot of the word error rate per gender, so with women speakers, men speakers, and overall. So with Caldi, I got like a smile curve, which indicated that the more women and the more I approach a gender-balanced training set, the better the performance is. So the word error rate was getting down, and above 50% it increases again, so it becomes worse, which is kind of the expected. With Whisper, however, it was more fluctuating. So it wasn't necessarily the gender balanced was the best. The best was around 70%, which was, it had the best performance for both and the fairest as well. So each model had a different outcome, but the gender did have an effect. The gender distribution did have an effect on the performance. So I took this further and explored other factors that could influence the performance. So I looked at the text. So the text that the speakers were reading in the training set, if it had any influence, but neither the difficulty level or the similarity between the train set and test set had any difference. So the text had no influence over the differences that I was seeing. I then looked at the pitch distribution, so the pitch ranges of the speakers in my train set and test set, and I found that actually when the model sees more pitch ranges, it becomes better. So it's more likely that it would see it in the test set if it has seen it in the train set. So there are more than one factor that we need to be looking at to achieve a fair model, not just the gender ratios. So with the pitch distribution idea, since it had an influence, I took this further and augmented data. So it's more of an idea of what can we do to make a model that hasn't seen much pitches, what can we do? So I used the same data set and artificially created more data by modifying the pitches, and then selected the speakers with pitch ranges that the model is lacking, basically, and I added that to the training set. So basically, I was trying to have a normal distribution of pitches in my train set so that the model has seen more pitches. And what I found is that this, in fact, had improved it. So it lowered the word error rate, as well as reduced the bias size, so the performance gap between the men and women. So the pitch balance data set did have the overall better performance and a fairer system. So this is what I did in my initial studies, and these are all types of playing with the data and considered part of the pre-processing. So what I just explained to you are pre-processing techniques, which is before the training, we're trying to do something to make the model better. But there are other strategies, of course, that does with the points of intervention. Previous research showed that post-processing is the least effective, so I'm not going to be doing that. I'm currently investigating the in-processing techniques, and hopefully the goal is to find something that would make the performance better, while also having a good, a fair and a good system overall, which would probably require combining multiple methods. So this is what I'll be doing, but you as well can have a role. You can contribute to having more fair speech technologies. So if you are a developer, you need to ensure that you evaluate your model on fair speech data sets, so you can make sure that it will work with different people backgrounds. Recently, Meta has released fair speech data sets, and also casual conversations contain both images, video, and speech. The QR code is just to point you to the datasets pages to download it. There are also many available toolkits to assess and evaluate the fairness of your model, of your AI model in general, if you are using it. If you're not a developer but a user, you can, or you should be transparent about the use of AI in your systems so that your listeners or anyone affected by your system can be aware that there is AI and can be accountable for that. It's not if there are errors. And you could also be sure to revise the auto-generated transcripts because they can contain errors. AI is not perfect, so you need to be aware of that and you need to recheck. And finally, it's important to engage with the researchers and developers and to give your feedback and share your thoughts so that they are aware if something is going wrong. So yeah, that's basically it. So in conclusion, speech technologies are biased, and my research so far showed that the gender distribution in the training set does have an influence, an impact over the performance. And there are multiple factors that could be affecting this. It's not just the gender ratios we need to be looking at. And you also have a role by being transparent and evaluating your systems against fairness. And hopefully by the end of the PhD, I'll be a step closer to achieving that. But yeah, there is still hope. So hopefully we'll get to a fair speech technology soon. And that's it. Thank you very much for your time and attention.
We could hear your first bit as well, so don't worry about that. Thanks very much for that. Now, questions on that topic. Here we have one down here. If we can have the cube. Thank you.
It's fascinating to hear what you say. I'd like to know where you are with the final thing you said about the human in the loop checking what the AI has done. Is there any element of machine learning so that when the human does check it and correct the AI, that gets fed back in so that it doesn't make the same mistake so often, and how long that process takes for it to become better and better?
Well, yeah, that's a good question. It does, in fact, feed back whatever you're feeding back. So ChatGPT, for example, has a thumbs up and thumbs down, so you can report if it's biased or did something offensive, and that is fed back to the model. Alexa as well, I believe, it gets accustomed to what you're saying, so it works better based on what you're saying. So you're using it does influence the way the model is being trained, so it's ongoing. But it's important to actually report it and flag it so that it knows that it did something wrong, basically, so that it can correct itself. So yeah, if you do something, it actually gets, it is effective.
Thank you.
Next question on this. Quite a few here. Let's go. Sorry, over there first, please. Thank you.
Thank you. That was very interesting. I wanted to ask, when you talk about pitch balancing, is that the right term? What do you mean by that? And does it involve making female voices more similar to male voices?
Good question. So the pitch balance just refers to the ranges of the pitch. So I wasn't playing with the gender, so it wasn't, because women pitches are usually higher than men. But if I manipulated a men's voice to be slightly higher or lower, it does not change the gender. The change is not that significant that it would change the gender. So when I say pitch balanced, it's referring to the pitch ranges. That's in the training set. So it has more of a normal distribution. So not dominant of, the high pitches is not more dominant than the other lower pitches, for example. So to have more of what's less represented, basically, if that clarifies. Did I answer your question?
Does that mean that women use a wider pitch range than men?
Yes, so biologically, yes. Women would have higher voices, higher pitches, yes.
Great question. Could you throw that over there somewhere to the person who's going to put their hand up again? There we are. Thank you.
Nice catch.
I was going to ask how much effect how fast people speak has, because I know sometimes it's been said that if you speak too slowly to someone who's hearing impaired, that can make it more difficult to understand. Equally well, we know people who speak very fast, and it's hard for a human to keep up with them.
That's an interesting question. I haven't explored the speed of the speech myself to answer that question, but it does definitely have an effect in general, because even us as humans, it does affect our interpretation. So for machines, it's the same. And for example, the tongue twister I mentioned, usually if I said it even faster, I said it slower, but saying it faster would also affect the interpretation of the model. So it does have an effect, but I cannot say for sure if it's better or worse, because I haven't.
Actually, a tongue twister will inevitably, you can't say it too fast. That's the whole point.
Yeah, exactly.
Great stuff. Thank you. Would you like to throw that one over here now? Thank you.
It did not see it coming.
What's my name?
All classes are question. That was an assist. I appreciate it. Just thinking actually off the back of the second from last question, with the range of tones and pitches across the voices, like, are you at a point where you're classifying these voices as like the same way you would like an orchestra with like a tenor or like a bass? Or I'm not super well versed in actual orchestral music, as you'll be able to tell, but
you sound as though you are.
do you go, how do you look to sort of like classify this? And maybe just an extra element of where I'm thinking is as you talk about the nature of it, you struggle to get a fair range. Is it like in a situation where, similarly, like in situation like giving blood, there are certain categories that we need more of, and that we need to outreach to certain demographics and stuff like that too? Somewhere in there there's a question, I think, loosely.
So with regards to it's not certain categories, it would depend on the data set itself. So depending on the analysis of the data set, if there is certain demographic that is a minority or a majority, then based on that we can adjust it to increase more of the underrepresentative. So it's not one thing. I forgot the first part of the question. The pitch. It was about the pitch distribution.
Just in regards to like how you classify it, and if it's to look at it the same way that I would like a musical scale.
So it's not. So there's no classification as part of this. It's more of measuring the pitch, so to have it as a mean pitch value of each speaker, and selecting it based on the value of the pitch. So it's not classifying it as just a selection of certain pitch numbers, basically. Okay, that makes sense. Thank you.
Yeah. Great stuff. Oh, sorry, one final quickie over here. This is going to be a record-breaking.
Close. It was close.
Well, first let me compliment you for the presentation, because it was really fantastic.
Thank you.
Very
Thank
clear.
You very much.
Last week I was looking at a television program in the Netherlands about AI glasses, specifically for people who are hearing impaired, and they wear glasses. That's a new technology, and they get automatically a subtitling, but on their glasses. So people who are hearing impaired. But if I listen to your presentation, I have my doubts if this is successful. So I think that would be a good opportunity for you to look into that part of the business, so to speak. So.
Certainly, yes. I hope they are doing the essential tests for that, so that they are making sure it's fair. But yeah, I think if the project is out there, it has gone through rigorous testing. So I just hope that it's accurate enough to be on the lenses.
But a great thing. Go for it.
Yeah, thank you.
Thank you. And just one very final thing from me. Is there anything we can say to consumers who have difficulty in communicating and they're just shouting at it louder and louder and it's getting more annoyed and still not responding? Is there anything we can say to users?
With regards to...
How to get your smart speaker to do what you want it to?
I don't have a direct answer to that.
Hend, thank you very much indeed. Thank you very much for a great presentation. Thank you.